Okay, let's look at Prep Test 24, Game 4, which is from December 1997. In this game, they give us 9 treatments, and we are supposed to select 5 of them. So it's an in and out game because we're just forming one group, which is, I guess the regimen of treatments that a patient is going to get. The one thing that stands out about this game is that the 9 treatments that we're selecting from are further divided into 3 categories. We have antibiotics, dietary regimens, and physical therapies. So there's 3 of each of these treatments in each category. And whenever you get in subgroups in a grouping game, any kind of grouping game, but especially in an in and out game, you need to pay attention to how many you're going to be choosing from each subgroup. Uh, Now, we don't know this up front, but in the rules, they usually give you some information that relates to that. And when they do, you need to pay a lot of attention to it because it will go towards the distribution meaning how many you're going to be choosing from each subgroup, and that's going to normally be really important in solving these kinds of games, right? With that in mind, let's look at the rules. So the first rule says we have a maximum of 2 one second. The first rule says we have a maximum of 2 antibiotics. Actually, the way they put it in the game, it says if 2 of the antibiotics are prescribed, the third antibiotic cannot be prescribed. So that's just another way of saying we have a maximum of 2. Uh, and then the next rule says that there must be exactly 1 dietary regimen. So that's easy to write. You'll notice that the first 2 rules both have to do with what I was just talking about, which is information about how many we're going to be drawing from each subgroup. Um, and when we put these two together, right, we can have either 1 or 2 for the antibiotics, and we're going to have exactly 1 dietary regimen. So then we can also figure out what's gonna be the range for physical therapies. We can talk about that a little more concretely in a second, but I think you probably get the picture. It's not that complicated. So the next rule says if O is not prescribed, then F cannot be prescribed. And I just wrote it in the contrapositive form, which is that if F is prescribed, then O would have to be prescribed, just because I think it might be a little easier to write that way. Um, the next rule says if W is prescribed, F cannot be prescribed. So that is not too difficult. That pretty straightforward. So we have 2 more rules. The next rule says G cannot be prescribed if both N and U are prescribed. So if both N and U, then not G. Okay, and the last rule is that V cannot be prescribed unless both H and M are prescribed. So this is just like the previous 3 rules. This one is again a conditional statement. Some people might have trouble writing this rule because it involves the word unless, but hopefully you know how to do that. If not, you can check back on the conditional reasoning lessons. This rule amounts to saying if V, then both H and M have to be selected. Okay, so those are the rules, and I think that the main thing that I want to remind you about again is that um, when you get a game with subgroups, the variables that you're selecting from are in subgroups, you need to pay attention to how many you're going to select overall, obviously, but also how many you're going to be selecting from each particular subgroup. And let's do that now because when I say you need to pay attention to how many you're going to be selecting from each particular subgroup, what I'm saying is pay attention to the distribution. Uh, and so there are actually just 2 ways it can go, right? Because there's a maximum of 2 antibiotics. So we can either select 1 antibiotic or we can select 2 antibiotics because we know that he's going to prescribe at least 1 from each category, right? So let's say we always know the dietary regimen is 1. So we're looking up here in the green box now. We know the dietary regimen is always going to be 1. So then we could either have 1 antibiotic, in which case to get to 5 total, we would need 3 physical therapies, or we could go 1 dietary regimen, 2 antibiotics, and in that case, to get the 5 total, we would need to use exactly 2 physical therapies. Okay, so those distributions are going to end up being really important, and especially it's going to be important to remember that we're only allowed 1 dietary regimen. Okay, so we'll look again at these distributions when we start evaluating specific. We'll start looking at these conditional rules in the context of the distribution that we just figured out. There is one deduction before we get to thinking about the rules and the distribution, how they interact. One rule that looks promising is this rule, which says if you have V, then you have H and M, um, because of the fact that you can only have 1 dietary regimen. So when we go if V, then H and M, then as soon as we go M, we can't have N and O because M is a dietary regimen and you're only allowed 1, so the other dietary regimens are automatically excluded. So if we have M, then we have not N and not O, and if we have not O, then this rule applies, right? In its contrapositive form, relative to what I've written here, it would be not O, then not F. So if we have not O, then we have not F, okay? But that doesn't completely tell us what's going to happen when we choose V. We have some information, but we don't have a complete solution. And the reason is because it's going to depend on which distribution we go into. Um, so, for example, if we already have the H, okay, so if we decide to go with this distribution, one dietary regimen, one antibiotic, and three physical therapies, then this H would be the antibiotic, and M would be the dietary regimen, V would be one of the physical therapies, and then we would have to choose the other two. That would be one way to complete the solution. And then the other way to complete the solution would be if we did it in this distribution. Again, M would be the dietary regimen, H would be one of the antibiotics, but now um, we would need another antibiotic, and then we wouldn't choose all the physical therapies, we would just choose two of them, okay? So how we complete the solution will depend upon which distribution we're in. So this is an important deduction to make, but I feel like the more interesting ones are the answer to this question. The more interesting deductions serve as the answer to this question, which is which two treatments can never be used. Now, I myself, of course, I'm doing the video, so I know the answer to that question, but I thought it might be a good exercise for someone who's tried the game and didn't have success at it to now try to figure out which two treatments can never be used. And the reason I say to try it now is because maybe you didn't think about the importance of the distribution ahead of time, or maybe you had messed up one of the rules or something. So I think it's a good exercise. So what you might be able to do is pause the video here and then try to figure it out and then come back, because now I'm going to move on to discussing the answer to this question, and you can pause it and see if you can get it right on your own, okay? But now I'm going to pick up and pretend that if you did pause the video, now you're back and you have the question completely answered, and you just want to see what I'm going to say about it. All right, so let's think about these two distributions, and that will serve to answer this question, okay? While we're exploring these distributions, we'll learn more about the game, but we'll also get the answer for this question. So one distribution we said was going to be one dietary regimen, one antibiotic, and three physical therapies. So this is not that bad because we automatically can say, all right, well, three physical therapies, that's all of them. So let's put the U here, and the V here, and the W here. Make that bigger so people can see it. Uh, and then what happens? Well, we have this V, right? And so since we have the V, then we know that this rule over here applies. If V, then H and M. So we have to put the H and the M in. Now, that works out, though, because we need exactly one antibiotic, which is what H is, and we need exactly one dietary regimen, which is what M is. So it looked like it might be a problem, but it works out because we had two very specific needs, and the rule, if V then H and M, actually fulfills those two very specific needs, okay? So if we go with the 1-1-3 distribution, three physical therapies, one antibiotic, one dietary regimen, this is the only solution available to us, all right? So, by the way, going back to this question, which two treatments can never be used? Well, we know that none of these treatments are going to be the answer to that question because these all can be used in this particular solution, okay? But what about it here? One dietary regimen, two antibiotics, two physical therapies. So now I need two antibiotics, and this is where we're going to put them, okay? So remember, the antibiotics are F, G, and H. So we need to choose two of these. And theoretically, we could just go FG, FH, or GH, right? There are three ways we could do it. But it turns out that not all of those are going to work out. Okay, so let's just look at it really quickly. Actually, instead of just trying it randomly, let's think about what antibiotic might create some problems. Okay, what antibiotic do we have a lot of rules about, or at least some rules about? And when we think about it for a second, we notice the F is in both of these rules, so that I'm telling you that this is a question you need to be thinking about. These might give you the start might give you a start to help answer that question. Let's think about that. If we choose the F, let's say we choose the F, okay? If we do choose the F, then we know that we cannot choose the O. Oh no, sorry, we have to. Sorry, then we have to choose the O. And if we choose the O, then that means that we can't choose the M, and we can't choose the N, right? And if we can't choose the M, then this rule, the contrapositive of this rule, says that, well, the contrapositive is if not H or not M, then not V. So in this case, we have not M, which means not V. So V has to go out as well. I'm just writing the ones that are out underneath here, okay? So V has to go out as well. We still need two physical therapies though, right? So the physical therapies would have to be U and W. But now you guys that stopped the video and tried it on your own are pointing out, right, that W and F can never go together. So just by putting the F in there, we then just followed the deductive process that is dictated to us by the rules, and we were led to a contradiction. Once again, it was if F, then O. O means that M and N are out. If M and N are out, then V has to be out as well, because if M is out, then V has to be out as well. And if V is out, we would be left with U and W to fill the 2 spots for physical therapy. But the problem is that W and F cannot be together because of this rule here. Okay, so one of the answers, one of the treatment that can never be used is F. Okay, so F is never going to be used. So now let's figure out if we can figure out the other one. So if there is a solution to this distribution, it's going to have to be G and H, because we just figured out that F can never be used. And the reason I'm saying never is obviously it can't be used in this distribution. The antibiotic in this distribution is going to be H. And if F can't be used in this distribution, since these are the only 2 distributions possible, then F can never be used. All right, so now we're looking for a solution. Is there a solution for this distribution, or is this whole distribution entirely impossible? Well, if there is going to be a solution, it's going to have to involve G and H. Okay, so let's figure out what happens there. If we choose G and H, actually we don't get a lot of action triggered, right? In fact, nothing really happens. Seems like there could be multiple ways that we could fill this out, right? Let's see. So one thing we know is that for this we have M, N, and O. Okay, for the dietary regimens, we have M, N, and O. Because the reason that I want to push this a little further is because I told you that there's 2 treatments that can never be used. The first one that we just reviewed, the fact that F can never be used, I think a lot of people, if they think about it for a second, it might come naturally to them, because they'll start with this over here, this fact that F can never be used, and then they'll follow that out and be like, sorry, this point that if F then O, and then they'll follow that out and say like if F then O, and if O then not M and N, and then they'll keep following that out and they'll get to the contradiction and they'll say, wait, that's weird, but F can never be used. But this one I think is less intuitive, and it's less likely to be figured out ahead of time. But they are going to ask you for it. So when they ask you for it, you would probably do it by process of elimination. But because I specifically told you that there's 2 treatments that can never be used, and I'm telling you that ahead of time, I think we'll just go ahead and figure it out ahead of time, rather than the more natural way that you would figure it out on the game, which is when they ask you for it. Then you would use your old work and look at the ones that could be used, and by process of elimination, you would get to the one that couldn't be used. Okay, but we're trying to figure it out ahead of time. So let's think about it, because we know that all of the physical therapies can be used, and we know F can't be used. So we're going to have to use G and H if we're going to come to a solution here. So if I'm telling you that there's one other guy that can't be used, it must be one of these, M, N, or O. Okay, but we know we can use M. So M can't be the one that's not able to be used. So let's stop worrying about the M. Even though, the M might be able to be used in the solution, really what we're trying to get at is who can never be used. So the answer's got to be either N or O. Okay, so let's try it really quickly. Let's just say we try the O. If we put the O here, then the M and the N are both out. And because the M is out, we're doing the same analysis that we did before. Because the M is out, then the V has to go out as well. And if the V goes out, then this has to be U and W. Okay, so we just want to check, is this solution valid? If it is, then that means the O can be used. And as it turns out, this solution actually is valid. So therefore the O actually can be used. The answer must be the N. Let's just really quickly figure out why the N can't be used. So remember, I should just take this off, and let's just say we put N here. Okay, so if we put N here, then again, it's the same deal. M and O are out, and because M is out, then V is out. So this has to be W and U, same exact analysis. And now, when we look and check to see whether this solution is valid, we run into this rule over here, which says that if N and U, then we're not allowed to have G. But the only way we're going to be able to come to a solution here is by using G, because remember, we need 2 antibiotics. We've already figured out F can't be used. So if there is going to be a solution, it's going to have to involve G. And then when we put the N into the solution that's going to have to involve G, we realize that we run into a contradiction, because the N will dictate the U, and in this distribution, the N will dictate the U, and that leads to a problem, because when we choose the N and the U, then we're not allowed to choose the G. Okay, so hopefully that shows you clearly why N cannot be selected either. So the 2 treatments that can never be used are going to be N and F. All right. Now, there might be a couple other things you notice in the setup, but I think I'm up against a time limit. So I think it's fair to say that with this setup, especially if you know that F cannot be used and N cannot be used, the question should not pose much of a difficulty, but I will do them in the next video. All right.